Hi everybody, this is lesson 2.6, Inflation and CPI. This lesson introduces us to a very important and interesting financial instrument that allows us to understand how value of currency change over time. Now let's read the specific objectives. Students will understand that changes in the purchasing power of the US dollar can be tracked using indices such as the CPI U. Comparison between dollar values across time can be measured in actual currency or inflation adjusted dollars. Students will be able to distinguish between changes in value measured in actual dollars and inflation adjusted dollars. Use the CPIU to measure inflation and make comparison between the relative expensiveness of products over time. Assess the effectiveness of inflation upon participants in an economy. Alrighty guys, so one question that I would like to ask you right away. What do you know about inflation? Can you just write a sentence or two describing it? Go ahead. Alrighty, so let's start our lesson. The problem situation number 1, a century of price change. That's the title of that problem situation. Alright, so we see a chart below that tracks the average price of a movie ticket in the United States over the last century. So the question number 1 is simply asking you to read this chart to estimate the average price of a movie ticket in the year 1940, 1970, and 2000. So take a moment and write down what are those prices. Okay, so it looks like that in 1940, the movie ticket will cost about, it's right here. It's relative, so it's less than half a dollar. So maybe like 20 cents. Sounds reasonable. Looking at the chart. Year 1970, if you go up, it's right in between a dollar and a two, so $1.50. And in the year 2000, the movie ticket was about, maybe right here, about $5 maybe and 20 cents. Again, these are all estimates. Alrighty, so as you can see, the prices have been going up, but is that a full picture? Well, we'll take a look in this lesson. Question number 2, what do you think is the main reason for the changes seen here in the movie ticket price? So why do you think the prices were going up? Can you write a couple of reasons? Alrighty, so let's review. Well, you might have said that maybe production of movies became more expensive. Maybe people were more interested in going to the movies, so there are more people watching the movies, going out. Or maybe you've said that it's just that it's not that the prices are actually going up just because of those factors. Maybe there's something about the fact that $5 that we pay in the year 2000, $5.20, is not the same as paying for the movie ticket $15 in 2021. Maybe there's a relationship between those numbers somehow. Okay, so the focus of this lesson would be not to look at just the nominal values. Nominal means the face values, what you actually see as a number, but we need to put that in a context of the time. And that's what we're going to try to do. So look at this chart. I think at some point in one of the lessons talk about measuring something in different dollars, and that's what we will be actually studying in this lesson. Remember when we were adjusting things to the minimum wage, there were those bar graphs? So this is similar. So this one, if we read the title, is the price of a movie ticket in the 2016 dollars. So it says use the chart to estimate the average price of a movie ticket in 2016 dollars in 1940, 1970, and 2000. So we'll try to understand what that means as we go through the lesson. But for now, looking at that chart, can you just say whether those prices are in those 3 years? I'll give you a moment to read the chart. Alrighty, now let's review. So the year 1940, we go to the chart. Looks like it was, almost exactly $4. Looking at the year 1970, so we go up from 1970, so it looks like there's like a peak here. Was almost $10, a little less than that, so maybe like $9.80. In the year 2000, we go all the way up, maybe here, so it's under 8, so maybe let's take off 20 cents, so $7.80. Alrighty, now it's unclear what that means in 2016 dollars for now. We'll explore that as we go. But you can see that this chart is talking about the price of movie ticket, but it doesn't look the same. Correct? Here you see the chart that's always climbing. Here you see the chart that's picking up, in 1 year, and then it's kind of fluctuates. And the numbers are much higher as well. Again, keep that in mind. We're not ready to answer this, like in terms of what does this all means. If it means something to you, describe it. And this is where the question 4 comes in. It's asking us, in which of the above 3 years was it most expensive to go out and see a movie? So looking at these both charts, when would you say it was more expensive to go to the movie to go to the movie theater? In which year? When? I'll give you a moment to express your opinion. Alrighty, again, there's no right or wrong answer yet, because we're still trying to understand what that means. You might say, well, look, the movie ticket is just going up. So the further up you go, it's just still climbing. Like, for instance, 2021, the average movie price, well, in New York City, for example, it's close to $20, correct? So it's been climbing, and you might say, well, now is the most expensive time period to go to the movies. Well, that might be an answer, sure, that's acceptable. But one of you might, or some of you might have said, well, no, 1970 was the most expensive, because if you adjust it to 2016 dollars, whatever it cost in 1970, which was $1.50, in the 2016 dollars, it's worth almost $10. Again, you might not understand what that really means, but just looking at the chart, you might say, okay, that might be the reason. Again, we're not going past the year 2010. However, just by reading that chart up to 2010, it looks like 1970 has the highest cost. But it looks like after 2010, it started to catch up. Well, again, we're going to explore it. I hope this kind of sparked your interest to talk about money in 2 different ways. One is just by like time machine, where you just go in the past and you just look at prices and see how much they cost. While on the other hand, you're looking at the prices and you compare them to a different period of time. And that's something we're going to develop by the end of that lesson. Okay, so again, answers for 4 will vary. We're going to continue going and reading other charts. So now this is the price of eggs. And once again, we have a nominal price in blue, which is this line graph. All right, that's just telling you how much eggs cost, like for a dozen. So like in the year 2010, it's about $1.50. All right, for a dozen. Now it would be maybe around $2 for a dozen, $2.30, something like that, depending on which kind. We're just talking about regular eggs. And then you look at the other chart in this lime color, where it actually telling us that in the year like 1920, 1930, 1910, the early 20th century, if you adjust it to $2016, again, we don't understand exactly what that means, but once you do adjust it, it looks like the actual price of eggs were declining. So what would you say? Have eggs gotten more or less expensive over time? What would you say? I'm gonna give you a moment to express your opinion. All right, so again, there's no right or wrong answer. One of you might have wrote, or some of you might have said, well, the eggs were kind of increasing in price and they were getting more and more expensive. You know, not too fast, but they were becoming more expensive in the dollar terms. But maybe some of you said, well, when you adjust it to the $2016, then actually the prices of eggs were becoming cheaper. Well, just again, looking ahead, this graph right here tells us a better picture than the other, because that put things in perspective. It basically compares the past to some other year. And in this lesson, 2016 so far is the year where things are compared to, but you might as well choose some other year like 2021. And by comparing them to that year, all right, it looks like the prices were declining. And you might say the reason for that, because there were advancement in farming, new technology. It's much easier and less costly to farm chickens and get eggs, and therefore the prices were actually declining, which is the truth, right? The prices of eggs have gone down the same way as many other products that are produced, through farming. Alrighty, now we're gonna go ahead and do some calculation. Ready? So this second problem situation is talking about Big Mac and the CPIU. So the Big Mac, we know what it is. It's a popular hamburger sold by McDonald's, and it's been around forever. All right, it's considered to be the most famous burger in history, and because it has a long history, then we can talk about its cost and somehow maybe see, because it's been around for so long, we can see the price change in Big Mac and compare perhaps to other stuff. So first of all, just open up question before we're doing actual calculation. What do you think do you think a Big Mac was more expensive in the year 1968 or in 2016? What do you think? What would you choose? Give you a moment. All right, so you are marked that both of your choices were correct. So actually, it's impossible to determine. That would be the correct response. You might say, what do you mean impossible? 357 is a higher number than 49 cents. Well, sure, but we're in different periods of time. It's impossible just to say, well, yeah, it's a larger number and therefore it's more expensive. No, that's not enough. And that's the idea that we're going to develop in this lesson. Having a larger nominal number does not mean that it's more expensive. Okay, it's not. And that's something that we're going to explore right now. We're going to put in and describe a very important index in finance, in economics. So there's a tool that can be used to compare the relative expensiveness of goods and services over time. This is called the CPIU, which stands for the Urban Consumer Price Index. So CPI is a consumer price index and U is for urban areas. The CPIU takes a weighted average of the prices for goods in a given year. Put more crudely, the CPIU boils down to a single number that gives you the cost of buying things. While the prices of individual products may change for special reasons, the CPIU is the average. You add all the prices and you divide it by how many, right? So that changes between these numbers. And so the changes between these numbers, called indices, across the time is primarily a result of inflation or deflation. In turn, the CPIU is one of the most frequently used statistics for identifying the periods of inflation and deflation. So those words, inflation and deflation, is what we're going to discuss quantitatively, right? Using numbers. So here's the chart. It goes by 5 years all the way to 2015, and it gives you an index. We want to understand what that index means, but what this description tells us is that it's average of the prices and goods in a given year. Sometimes you can think of a cost of a basket of goods. So that basket includes rent, food, transportation, personal items, everything goes in that basket. And you average it out and you produce a number. And the CPIU as an index. It doesn't have any units, but it gives us an idea how things cost in a given year. The bigger the number, listen to this, the bigger the number, the more money you need to buy the same thing. So here are the numbers. We're going to refer to them, and we're going to look at the first question in here to try to understand specifically what that means. Ready? So let's look at these very, very carefully to try to boil down what that index means. For now, the takeaway, the bigger the CPIU, the more expensive things are. But then the question is, how can it be used to measure inflation or deflation, or what does it even mean? So let's go ahead to number 7. It says, one conclusion that can be drawn from the table is that the product that cost 20 cents in 1920 would be expected to cost $2.37 in 2015. Okay, so let's break this down. So we have 2 years that were chosen to compare. So one year is 1920, and the other year is 2015, and we have the CPIU index. And if you look at the chart, the number for CPIU in 1920 is 20, and the number for 2015 is 237. It's the highest one. So one interpretation that that it's made right here. So you're gonna think of this in terms of the dollars. If something costs 20 cents, if you touch the cent here, then that same thing in 2015 is gonna cost 237 cents. That's one way you can interpret it. Or you can say something that in 1920 cost $20, in 2015 is going to cost $237. Relative, remember, it's an average cost for everything. So if what would cost $237 right now that also was available in 1920? All right, so we can talk about technology. So maybe for 237 you could buy maybe lumber, like wood and stuff. I don't know, nothing comes in my mind at this point. So let's say $237. So maybe a couch. Let's talk about that. It's a furniture store. And then in 2015, because right around 1920 is when people started to move in the United States, and the family started to settle, and I guess the furniture was around, right? So let's say something that costs $237, let's say some kind of table, right? Or couch. And in the year 1920, that's comparable thing would cost you $20. Do you understand the idea? That index puts a numerical value to goods. The bigger the number, the more expensive something is. Okay? Alrighty, so now if you take that idea, as CPIU gives us the idea of how the prices change, we're going to look at the product that cost $36 in the year 1945. Oh, it says 1945. So we better make another table, okay? So let's get rid of this, and let's go ahead and put the information for that other year. So the year 1920 and 2015 was just a way for us to see what that CPI means. But now let's look at the specific years. All right, so let's fill this table. We got 1945 we have 1950, and we have 1975. So these are the years that were chosen. Okay, let's write down the CPI-U for each one of that. I'm going to write it for you from the table. So 1945 is 18, 1950 is 24.1, and 1975 is 53.8. Again, you can think of these as dollar values of something, you know, an average cost of something. And it has been climbing, as you could see. And now we're going to look at the product. It doesn't say which kind, but we're going to just like a product that cost $36 in the year 1945. I'm going to give you a moment and see if you can find a price of a product in the year 1950 if you use the fact that the CPI has risen from 18 to 24.1. What would be the price for 1950? Let me give you a moment to think about this. All right, so it's not a simple question. And the way you can address this is by observing what's going on. All right, so let's take a look at a couple of things. I'm going to give you a couple of strategies, and you choose the one that you like the most, okay? So one way we can also see that is to calculate in this chapter. Remember, we talk about the relative change and an absolute change? Because we talk about the CPI is a relative index. So we want to calculate a relative change between 18 and 24.1. Let me give you a moment. Find the relative change between those two numbers. Okay, let's review. So to find the relative change, we're going to take 24.1, we're going to subtract 18, and we're going to divide it by 18, which was the initial value, and multiply it by 100 to get the percent. Okay, so let's do that. I'm getting 33.8%, and it's repeating 8. I'm gonna put a little hat on that. All right, so you know how you can interpret this percentage, and remember those words, okay, because I think that's the key to this lesson. This is measure the price increase of goods from those years, which is from 1945 to 1950. So in a matter of, 5 years, the prices has gone up by 33.8% on average across all the products. This is called the inflation. All right, so the relative change in CPI, it's either urban or not urban. In general, there's I think the urban is the one that's used to track the inflation. So the relative change in the CPI-U is called an inflation or deflation. So inflation is a rise of prices. Deflation is when the prices go down. So we'll have an example of deflation later on in this lesson. Okay, so now if the product that cost $36 undergone the same increase, that means we want to take the $36 and we want to add 33.8%, repeating, of that $36. All right, now using a little shortcut that we have developed throughout this course, you can just attach 1 to 33.8% and just multiply it by it, and you're going to get the same answer. Or do it the long way, be my guest, okay? Whatever makes sense to you. But I like to use this because this is quicker. So it's 36 multiplied by 1.33 and then bunch of 8s. So that would be $48.20. All right, so $48.20. All right, so that's an understanding of this. If you want to do it a little bit faster, you can go ahead and you can calculate the ratio of 18 to 24.1. All right, and if you do the ratio, if you divide 24.1 to 18, do it on your calculator, see what you get. You will get 1.333. Where should I write it? Right here. It's kind of an important number. So going to here, it's going to get multiplied by 1.33 and then 8 repeating. So once when you do a ratio that tells us how many times one number larger than the other. Okay, so if you do the same thing to this side, which by the way we already did earlier, you're going to get the same answer. So in other words, by whatever factor the prices increase, that's going to be the same factor that the other one would increase. Okay. Also observe the following. You see how it's 18 and you see how it's 36. You see how 18 is exactly twice as much as, 36 is twice as much as 18. So if the product costs $18, it would cost 24.1. So if you have $36, then it's going to double as well. And 24.2 multiplied by 24.1 multiplied by 2 also gives you $48.20, the same result. I would focus on kind of like the percent understanding, because that works for all the calculations that we need to do in this lesson. Okay, so take a moment and calculate that same product that was $36, but in the year 1975. I'll give you a moment to calculate that. Alrighty, so let's review. So to calculate that, again, you can calculate the the percent change from 1945 to 1975. So you will do, and you can actually use 1950, but I'm going to use the same number as before. So it's 53.8 minus 18 divided by 18. All right, so that gives us the percent change. You're going to get 2.98, well, it's going to be 198.8 repeating of a percent. Okay, and now if you take the $36 and you add 198.8%, so it's 0.1, well, it's 1.9888 repeating times 36, it's going to give you, so 1.9888 times 36 plus $36, so that gives you 107.6 about. Looks a little complicated, right? So, you find the percent change and then you apply it to a given number. So it's 107.8. By the way, notice that it's about twice as much as 53.8, which is fine. The next question helps you to, instead of calculating this relative change, it might be easier to do this using ratios. So that's what this question is asking us to do. Let's read it. The CPI-U was 34.8 in 1968 and 240 in the year 2016. Calculate the ratio of the CPI-U between those 2 years using 1968 as a reference value, the denominator. So now we're getting to the place where it's going to make our calculation a little easier. So let me summarize this for you first, and then I'll ask you to calculate the ratio. All right, so here are the 2 years. The CPI-U. So for 1968, the CPI-U was 34.8, while the year 2016 is 240. So go ahead and find the ratio of those two using 1968 as your denominator for the CPI-U. Go ahead, let me give you a moment. All right, so let's review. So the ratio is 240 divided by 34.8. Very important to read what it's saying. It says put the other one as the denominator, and we get an answer of about 6.9. Can you take a moment and write the sentence interpreting what that means? All right, so we have been emphasizing this for some time now in this lesson. What the CPI-U measures are the prices of goods in a given year. So when you do the ratio, remember the key word here is times. All right, so that means that prices in 2016 are about 7 times the prices in 1968. So the things are 7 times more expensive in terms of its nominal value. You understand? Using the nominal value, just the numbers themselves, to buy the same thing, now you need much more money. All right, so you need $240 to buy the same thing that you needed only $34.80 in 1968. All right, now let's look at the Big Mac and revisit our question in terms of the comparing the prices. So if from that question, from that first original information about Big Mac, which we were not able to answer, now we can. If we compare the 2016 price to year to the 1968 year price of that Big Mac, it was $3.51 divided by 49 cents, and we can measure to see how prices increase over that period of time. Notice we're doing a ratio, not the subtraction. Forget about subtraction. Subtraction tells us nothing. We want to know ratio, because ratio gives us how many times something increased by. All right, so the ratio here is about 7.3. So that means the Big Mac in 2016 is now 7.3 times as more expensive as the year 1968. Well, does that, what would you say? How does that compare to the overall inflation? What do you think? Is the price of the Big Mac is really increased by a lot, by significantly a lot? What do you think? You can write a statement. Well, you might have said, yes, it's 7 times more expensive, but then everything else became about 7 times more expensive. So Big Mac is basically tells us similar story as the CPIU. So we can still, like in terms of its face value, the Big Mac hasn't changed its price much by comparing this to the CPIU. It's the same one. But one thing that we still can't tell is about, things are getting more expensive, right? Because of its nominal value, but they are comparative to what they were in the previous year. Now the question is, can people afford it? And that is, kind of the last piece of that lesson that we want to revisit. Well, before we talk about that, that would be our last problem situation. Here, question 10 is asking us, using the CPIU, identify a period in which deflation occur. Deflation is when the prices are going down instead of going up. So if you look at this table, what were the years when the prices actually decreased? Let me give you a moment. All right, so that year was just before World War II, or around the time that World War II was starting, and that is right here. So between 1935 and 1940, and let's look, you also have at the beginning right here, right, of that table. So that's the period of deflation, and the prices has gone down for whatever reasons. Now, when the prices do go down, it's not necessarily a good thing. Okay, so deflation is not it might look good for the consumer, but it also can show that there's some uncertainty in economy as well. All right, again, this course is not in economics. What we want to do here is to understand just how to measure value of goods. All right, so question number 11, it's asking us, based on the above table, during which decade do you think Americans were most worried about inflation? Okay, so when was the time when people were worried most about inflation? So looking at those numbers, see where you can find the most significant jump, maybe like doubling or something becomes really significant. Over what period in the United States history based on this consumer price index? I'll give you a moment. Well, if you notice here, the years between 1970 and 1980. You see how it was 20, 29, 31, 38, but then all of a sudden it's like 82. Even you can go all the way to 1985 and see 100. This, if you compare, is more than twice. So the prices in a period of 10 years, prices gone up twice. So imagine right now you have, let's say, I don't know, the subway ticket is $2.75, and 10 years from now it's going to be all of a sudden like 6 for just one swipe. That's what has happened in between 1970 and 1980. This is what was the time of financial uncertainty in the United States. So that was pretty difficult time in the U.S. history. Alrighty, so now let's go on to the problem situation number 3, and just understand how does the inflation keeps up with the prices of other goods and just the your wages and stuff. So problem situation 3, the downside of inflation. Inflation causes the purchasing power of the dollar to decrease, meaning that with that $1, $10, you can buy less and less and less of goods as time goes by. However, if your wages are keeping up with the rate of inflation, like if you're earning more, while each dollar buy less, you are making enough money to buy the same amount of goods as before to compensate. The below graph shows that while the average U.S. hourly wage increased from $2.50 to $20.67 in 2014, the inflation-adjusted purchasing power of those wages have remained fairly constant. So now, again, we have to kind of understand what we're talking about here. So the numbers that are there, this is the average wage per hour. All right, so it's how much everybody earn on average per hour, and it has been going up. But if you adjust that $2.50 in the 1964 based on the CPIU index, you see, now we can understand finally what does it mean to adjust to that year. It means you have to compare it to the CPI. So that $2.50 in 1964 is like $19.18 in 2014, which is pretty comparable. You see, so even though the prices were going up, its purchasing power of buying goods has not fluctuate as much. All right, so the question is, as noted in the last problem, inflation can be an economic concern. Why might someone be negatively affected by the high inflation? Within you, well, it's saying talking about the group, but since we are fully online, can you think of a situation or two situations in which someone might be negatively impacted by inflation? So if the prices are going up, right, that's what inflation means, how can somebody be negatively impacted? So can you write a sentence for each problem that can arise, and we'll review. All right, so let's go ahead and talk about this. So currency, the dollars, right, becomes less in value. Okay, so what happens if the money is not invested? So money just lose. Yeah, I mean, we wrote it. Currency becomes less in its value. So if you don't invest your money, if you have some savings, the money is basically going to just eventually become less and less and less worthy. And if you don't invest them, then you're losing them. All right, so you're losing the value of those dollars. The other thing that could happen is that the wages do not grow as fast as inflation. So for example, someone can be hired for a fixed salary, and the salary will stay the same for a period of time, while as time goes by, the inflation is moving. So if your salary is not going up, that means that you will, if your salary remains the same, that means you will be not able to afford the same thing. It's going to become more and more expensive for you to buy stuff, because the products are going to increase in its price while you're getting the same money. Okay. Another good thing, another bad thing that can happen to, let's say, a bank, if the bank lends you the money at the low interest rate, so they only, they lend you at 3%, but the money loses, let's say, 5% its value in its year. Then what happens is that the bank is losing its money by lending it to you. So low interest rates are also, it's good for the consumer, but bad for bank. Now let's do particular calculation to finish this lesson. I know this one was a little bit longer lesson than the others, but we're almost done. There are 2 questions remaining. So question 13. In 2016, the bank is offering the highest savings account interest rate was Barclays. It was offering 1% annual interest. So whatever you invest in that bank, you will earn 1%. 1%. So you invest $100 in 2016. By the end of the year, you're going to have $101 in your bank. All right, so you earn a big 1%. I'm being sarcastic, of course. It's a very low rate. But in the same year, the inflation actually in the United States was 2.1%. And if you're being following current events in 2021, with the big government spendings, the inflation is the highest it has been in 2000s. Like it has not been high like that, like now. So the only time it can be compared to, it's the 1970s. So inflation is crazy high. So, and here's an example. So let's say someone invested, we say John, I invested $10,000 into Barclays account in the 2016. So what would be actually the purchasing power of that investment? The purchasing power is basically, what is its value now? Like, what happened to $10,000? I mean, it's going to increase in its value, but you can buy less goods with this because of the inflation. So look, if she is going to earn 1% interest rate, but then the money is going to go down by 2.1%, then the net loss for her, it's not that she's going to lose those dollars. No. It's just the value of those dollars is going to be 1.1% less. She's still going to have more than $10,000 in the bank. It will be more. It will be 10,000 plus 1%. Yeah, she's going to have, what's 1% of 10,000? $100. So she's going to have that money. Guess you understand. She's going to have that money in her bank, but with that $10,000, 100, she can buy less than what she could have bought with that 10,100 a year ago. So the actual purchasing value of that $10,000 actually declined. How much? Well, we're going to take 10,000 and we're going to minus 1.1% of 10,000, and I'm going to do this using the concept that we developed in lesson 1.3 earlier. So if something goes down by 1%, you can do it the long way, but a quicker way is to multiply this by 989. If you forgot, it's 100% minus 1.1%, which will be equal to 98.9% of the value. That's what we're calculating. And you can do it the long way. That's fine. Whatever way. But the result is 9,900 there. So she's going to have this amount of dollars in 2017. But this is the same as this in 2016. You see? It's the same. An interesting concept. All right. So a takeaway from this is that when you save money, you want to invest it, otherwise it's going to lose its value. And you also want to be mindful if you sign up for, you get hired, is to talk about what are the benefits in terms of the salary increases. Is it going to stay the same, or is it going to increase with time? And that's what the last question is about. Mario works for the city. His salary is called a fixed income because he's on a pay schedule, getting a 3% annual raise each year, and that's it. Suppose that 2017 Mario was making $50,000, and then suppose then inflation goes up to 5% in that year, just like this year, and it stays like that for 2 years. Calculate the purchasing power of his salary 2 years later in $27. So basically, his salary is going to go up 3%, but the inflation is going to make the increase 5% less. So it's going to go up 3% and down 5%. So the net effect is that Mario is actually losing 2% in his purchasing power, because of the fact that the inflation is pushing the value of the dollar lower. The actual salary that the Mario is receiving is going to go up, but the actual value of it to buy goods is going to go down. All right? So this is one of the quantitative reasoning why, printing money and just creating money with no actual value in it puts the economy at risk. Okay? And in this case, the net loss is 2%, so that means that his salary is going to change. So the first year is going to be 2% decrease. So that means it's 50,000 minus 2% of 50,000. Again, we're doing this so often that I'm hoping that you're understanding how to deal with these percent changes. Okay, I'm gonna do it long way, and I'm gonna do it the shortcut way. But if something goes down like this, that means he's gonna lose 10,000, right? Well, 1,000. So it's 50,000 minus 1,000, which is $49,000. That's the first year, correct? To do it the quicker way, and I'm hoping you are using this idea, is you take 50,000 and you multiply it by 98%. If it's a 2% change, and you're going to get the same answer, 49,000. And then the next year, he's going to lose another 2%. So another multiplication by 98, and that will give us 48,020. All right, so it's a complicated lesson. I wouldn't lie. I'm hoping you're going to go ahead and try the homework assignment and look, and hopefully you also took good notes so you understand how the calculation would go. On that, I'm going to end this lesson.